All right, so sometimes we're going to have to be able to rewrite trigonometric expressions or algebraic expressions in terms kind of each other and make some substitutions, or what we like to call substitutions. And so in the previous example, we looked at a sine squared minus cosine squared and was like, oh, that's a difference in squares. We need to be able to do that in multiple types of situations. So if I have 2 cosine squared plus cosine minus 1, I might say like, well, let's let x be equal to cosine theta. And if I do that, then this is the same thing as 2x squared plus x minus 1. So I need to factor this. And so what that would end up being is 2 cosine theta minus 1, and then cosine theta plus 1. All right, let's go ahead and look at another example. Maybe I want to write this function as, or this expression as a function of theta, and here's the substitution that I'm going to do, and it's just like giving us good values here. So this would be the only domain this would work for. But let's see what happens. So if I do 4 minus, and then in place of x, I put 2 sine theta, square it. Then I do 4 minus, okay, 2 squared is 4, sine squared theta. 1 minus sine squared theta. Well, 1 minus sine squared theta, remember we have sine squared plus cosine squared equals 1. So 1 minus sine squared would be cosine squared. Well, that would be 2 square root of 4 cosine theta. And so that would now be a function of theta that I'm replacing this here with. That would mean the same thing as this expression here.